Today I will discuss the crystal lattices and unit cell. Crystal lattices and unit cell. We know solid state of a substance is formed by the close packing of constituent particles. Close packing of the constituent particles. The regular repetition of the constituent particles the regular repetition of the constituent particles entire the whole solid is known as the crystal lattice because it looks like the net or lattice. In other words, the three-dimensional arrangement of the constituent particles entire the whole solid is known as crystal lattice of the substance. Suppose in crystal lattice constituent particles has been depicted by the solid sphere point, which is known as lattice point or lattice point. Each point in a crystal lattice represents one constituent particles, which may be an atom, molecule or ions. Sometimes it may be a group of atoms. Lattice points are joined by straight lines to bring out the geometry of the whole lattice of the solid. It must be remembered, crystal lattice has been three criteria. One of them is in a lattice point each point in a lattice is called the lattice point or lattice site. Crystal lattice represents each point of the crystal lattice represents one constituent particles. The constituent particles may be atoms, molecules or ions. Sometimes crystal lattice point may be of the group of the atoms. Lattice points are joined by straight lines to bring out the geometry of the lattice. It has been observed that there are 14 possible three-dimensional crystal lattices which are called Bravais lattice. So the type of the crystal lattices are 14, which is called Bravais lattice in honor of the French mathematician. Suppose we want to represent the crystal lattice in the plane of the paper. Suppose it is the cubic form of the crystal lattice. It is a simple form. Now it is bisected into two equal halves. As now it is further classified into two equal halves. So the total number of cube will become 4. Now each face of this figure has been bisected into 2. This has been it is the crystal lattice, a small part of the crystal lattice. This line may be foregoing in this way, in this way, in this way. ठीक है? Similarly, this line may grow in this way. This line may grow in this way. This is the lattice point. So lattice point may be the constituent particle. Lattice point occupied by the constituent particles. Constituent particles may be the atoms, molecules or ions, which may be the group of atoms. These are the constituent particles of the solid. Now this figure looks like This figure looks like 8 different units, 8 different cube. Suppose we named it 1, 2, 3, 4, 5, 6, 7, 8. So the small part of this unit will become this. This is the constituent particles. Constituent particle. It is 1, 2, 3, 4, 5, 6, 7, 8. Now we compare this figure and this figure. It looks like this is the regular repetition of this unit part. So it is the unit cell of this constituent particles. It is the unit cell of this crystal lattice. So the unit cells may be defined as the small fraction, that is a small part of the crystal lattice which is regularly repeated to form the crystal lattice. It is the crystal lattice, and it is the unit cell. So unit cell may be the small part of the crystal lattice by regular repetition of which we can get the whole crystal lattice of a solid. A unit cell may be characterized by two phases, two factors. One of them is the edge length, and other is the unit cell is a small a unit cell is characterized by the three edges. This is and this is three edges and three angles. Suppose it is the x-axis, it is the y-axis, it is the z-axis. In x-axis, the edge length is represented by A. In y-axis, edge length is represented by B. In z-axis, the edge length is represented by C. Suppose this figure has been rotated in this way. So it will become X, it will become Y, and it remains at Z. The angle between X and Y, X and Y is represented by gamma. The angle between Y and Z is represented by alpha, and angle between X and Z will be represented by beta. So there are 6 parameters by which a unit cell may be characterized. 3 edge lengths, say A, B, and C, and 3 angles which are represented by alpha, beta, and gamma. Thank you. In next class we will discuss the type of the unit cell. Thank you.